So, Math 102, Notes 10, page 2. If my plan goes well, I've actually covered this notes in class, but I thought, some people might miss class, so wanted to do a couple pages from Notes 10 just in case you did miss class. So, we're going to simplify expressions that have have fractional exponents. And we're not going to leave negative exponents in our final answer. Now, here's the thing you have to get kind of comfortable with. We now know that this fractional exponent is a radical in disguise. It's a cube root. But we don't want to change this to radical form necessarily. Generally, if your expression comes to you in exponential form, just keep it in exponential form. It's probably going to be easier to work with that. One of the things we want to be able to do is learn to be able to work with radical form, fractional exponents, and learn to go back and forth, because sometimes fractional exponents are easier to work with than radicals. Sometimes radicals are easier to work with than fractional exponents. It depends on your purpose. And right now we're just learning the skills. Later, when you come up with a problem, an application, you'll see which form is best, and then you'll have that flexibility to use whichever form works for your particular problem. So let's look at this problem. Notice, I'm still asking, how many terms? Well, that's all one term. Now, what do you notice inside the parentheses? What am I getting at here? Those are factors. Or you could say it's multiplication. Or you could say, hey, that's all one term inside the parentheses. Well, two things here. Exponents before multiplication, and since these are all factors, I can raise each factor individually to this 1/3 power. So this will be 3x times the answer that's going to come out, which will be -8 raised to the 1/3 power. I'm not liking this marker very much. X raised to the 1/3 power, and y squared raised to the 1/3 power. Now, some of you might be able to do some of these steps in your head, but with fractional exponents, it's easier to make careless mistakes. So you might want to just slow it down a little bit. So this is going to be 3x times. Okay, now I'm going to break my rule. When you have a numerical base, I will want you to calculate it. And the way you calculate -8 to the 1/3 is to realize, oh, that's a cube root. So we do go to radical form to figure out what -8 to the 1/3 power is. Well, the cube root of -8 is -2. So this is just times -2 times x to the 1/3. Right here, power to a power. It doesn't matter what the exponents are. Power to a power, you multiply, and 2 times 1/3, well, if you're going to double 1/3, you get 2/3. So that's y to the 2/3. Okay, and then we're almost done. 3 times -2, that's just -6. Okay, here, bring the brown back. We are multiplying the same base. It's long distance multiplication. You can write those next to each other if you want, but I'm just going to move them next to each other in my head. When you're multiplying the same base, you add exponents, and don't make this hard. 1 1/3. 1 plus 1/3 is 1 1/3. Change that to an improper fraction, that's 4/3. And then y to the 2/3. And then just leave it in exponential form. Okay, now, I left the harder one for you to try. So pause the video, give this one a try. Don't let the negative exponent mess you up. You know how to deal with that. Okay, I'm going to go ahead and go over this. This is all one term, and this is a big fat fraction bar, which acts like parentheses, which means find this answer and then divide it by that answer. So I need to do this exponents before the division. Negative 27 to the 2/3. Oh, by the way, let me comment here. That's multiplication, which means I can distribute the exponent to factors. I'm going to slow down with the negative 27 to the 2/3. And then I'm probably going to slow down with this, m to the 6 to the 2/3. All over. Now, you could go ahead and deal with this negative exponent at this time, but I kind of ran out of space, so I won't. Let's finish with the numerator. Be careful here. This is not negative 27 times 2/3. It's not the same thing. It's negative 27 raised to the 2/3. So remember, when you're trying to calculate the value of a numerical base raised to a fractional exponent, you want to go to radical form. So the denominator of the exponent tells me this is a cube root, so it's the cube root of negative 27, and the numerator of the exponent tells me to square this. So it's a two-step process. I take the cube root of negative 27, which is negative 3, and that negative is in parentheses, so I square that, that's positive 9. Okay, so this is scratch work for this problem here. So what I have is 9 times. Now this is power to a power. That is multiply the exponents. So, you know, that's negative 6/1 times 2/3, negative 12/3. That's just negative 4. So that's m to the negative 4th over m to the negative 5th times m to the 3/2. Okay, at this point in time, there's so many things you could do next. But notice, this is all one term, and that base m is showing up 3 different places. You could simplify this. We should only have to write that base m once. All right, so I think I will first raise the m to the negative 5th, go ahead and take the reciprocal, so that becomes m to the 5th in the numerator. And so this is 9m in the numerator, because when you're multiplying the same base, you add the exponent, so negative 4 plus 5 is 1, over m to the 3/2. Let me go ahead and write that 1. Almost done. So this is where, when you have fractional exponents, you sometimes absolutely need to use our general exponential rule. When you're multiplying the same base, you subtract the exponents. You write the base in the numerator, and you subtract the top exponent minus the bottom exponent. And you know, this is $1. You owe someone 3/2 of $1, so you're shy $0.50. So this is m to the negative 1/2. And then you say, oh, that's a negative exponent. I don't want to leave negative exponents in my answer, so send it to the denominator of that term, and there it is. Leave it in exponential form. All right, now we're going to look at the next one. It's really short. I threw it in just as a compare and contrast, because both of these types of problems will be on your midterm. I gave you the problem in radical form, so I want you to stick with radical form. In fact, it's going to be a whole lot easier to do this in radical form. So see what you remember. Turn off the video, try this problem, turn it back on when you think you have the right answer. So looking at this problem, I can't do anything with root 3x. I might be able to do something with root 15x cubed, but you know what? I don't want to have to work with 2 different radicals, because that's multiplication. I'm going to make one big happy radical. And I can do this in my head. 3 times 5 is 45. X times x is x to the 4th. Now I just have to think about simplifying one radical. All right, any perfect square factors already? Yep, x to the fourth. I don't need to mess with that. The square root of x to the fourth is x squared. Is 45 a perfect square? No. Does a perfect square divide into it? Yes, 9 does. So I'll write 45 as 9 times 5. And then these two factors are perfect squares. I can take the square root. So the square root of 9 comes out as 3. The square root of x to the fourth comes out as x squared, root 5. The 5 stays under the radical. Very simple problem if you stick with the radical form. All right, one more problem here, and then I kind of want to talk about something, sort of an add-on to these notes. So it looks nasty. It's not that bad, but try it. Pause the video. Turn it back on when you think you've got the right answer. Okay. So, lots of ways you could do this. I don't think I'll do it this way, but just in case you thought about it, I want to tell you this is okay. Since this entire factor is raised to the negative first, you could bring it up as to the positive first and multiply it there. So you could do it that way. You know what? I don't know. That's kind of the easiest way. I'll do it another way because a lot of you probably didn't think of it that way. So I am going to simplify in the numerator. And this is all multiplication, so I can just reorder. 3 times negative 2 is negative 6. X to the 1/4 times x to the 1/2. Multiplying the same base, you add the exponents. Now, if I do quarters and halves on your test, make this easy. That's a $1/2, that's a quarter. A $1/2 and a quarter is 3/4. So that's x to the 3/4. Okay. Then the y's, remember that's a y to the first. Multiplying the same base, it's long distance multiplication, but we're multiplying the same base. I add the exponents. Again, think you have $1, you lost a $1/2, so that's y to the positive 1/2. That's all that numerator is. And then, if you did pull this up, the numerator up, you could multiply these two together and get the answer. Probably the easiest way to do this. Maybe I will go ahead and do it that way. So if I pull this up, so I'm going to do this a couple ways. I would have negative 6x to the 3/4 times y to the 1/2 times 4 times x to the negative 1/3. And then negative 6 times 4 is negative 24. All right, I have x to the 3/4 times x to the negative 1/3 times y to the 1/2. So multiplying the same base, we should not leave the same base in that one term showing up more than once. Multiplying the same base, I have to add the exponents, so go down here in the corner. 3/4 plus a negative 1/3. LCD is 12. So I'll multiply this by 3/3. I'll multiply this by 4/4. So that's 9/12 minus 4/12 is 5/12. So this is going to be negative 24 x to the 5/12 y to the 1/2. So that was one way to accomplish that problem. Probably the easiest way to do it. Now, what if you didn't think to take this whole factor and pull it to the numerator? Well, what you would want to do, in fact, let me start with what you would not want to do. You would not want to flip this and make this a compound fraction. You don't want to do that. What you want to do is go ahead and distribute that exponent to the two factors. So this would be 4 to the negative 1, x to the positive 1/3. Okay? Then you go, well, that's a negative exponent. I can bring that up to the top. Remember the negative 6, that's a negative base. That's the opposite of 6. It is not the reciprocal of 6. 4 to the negative 1 first is the reciprocal of 4. So that moves up to the numerator. And then I still have the x to the 1/3 in the denominator. Well, I know negative 6 times 4 is negative 24. Then, if I am dividing the same base, I write the base in the numerator, I subtract the exponents, top minus the bottom. So that's the exponent, 3/4 minus 1/3. Then times the y to the 1/2. And look what we had over here. X to the 3/4 times x to the negative 1/3. I added those, but subtracting 1/3 is the same as adding the opposite. So it's the same arithmetic. It's going to have the same answer. That is going to be x to the 5/12, y to the 1/2. So keep in mind that, okay, I did this 2 ways. I could have probably done it a couple other ways. It still would have been fairly simple. So when I do an answer key, I'm probably going to do it just one way. So if you made some slightly different choices, but you got the right answer, then you're probably good. All right, so I have an extra thing I wanted to do, but this video got long, so I think I'll start the video with this little add-on, the next video I do.